We're going to be discussing 3D printing for the Coast Guard, amongst other things, including some more money from Core and a multi-material electronics 3D printing. So there's some. It's a very big bit of a mixed bunch for you guys, and I hope you like it. Now, the first thing is, I think this is absolutely a great case. I think this points to a lot of organizations doing something in 3D printing that we don't really consider, but it's something the technology is eminently suited for. At the Coast Guard, they are responsible for ATOL, aids to navigation. This can be anything from a buoy to a lighthouse to kind of some kind of signaling tool. And they're responsible for maintaining these things. They spend about $20 million a year, even though there's several $billion worth of this stuff all over the place. And they spend $20 million a year trying to update, maintain these things so that ships don't. Right now everybody has GPS, obviously, all sorts of things, but these things, do tell smaller ships that are not as well equipped that could interfere with bigger ships, and also people that have lost navigation, and they work as visual aids and cues to people who have tools, and a backup for if something if the other electronic systems won't work, like radar and stuff. And a lot of people steer by these things anyway. So a very important kind of legacy maintenance problem. Now, I think this is something that we see 3D printing being used a lot. It's not one of the most sexy uses in the world, but I think it's absolutely fantastic. Now, what these guys have done, they saved $650,000 in repairing a total of 150 parts. One of these is it's kind of like a rotating light for a lighthouse. And they had to make, like, the housing. 3D printing is eminently suited for housing, and they had to make some other components of this. And they designed this for this incandescent light bulb rotating beacon. They've also done things like switches, and these may seem like very simple components, but think about this. This use that saves these guys $650K. Now, the people in charge of this are going to be doing a 4-month training with commercial partners, a couple-week training with the Navy, and they're going to be doing many more things going forward. And imagine just the stuff that these guys could be doing with casting and wax, and all sorts of other technologies as well. And I think anywhere you have a lot of legacy equipment, that there's a beautiful case for 3D printing and maintaining things, especially if they're out of repair. You can't even get them, or you can't in any way, shape, or form replace them because they just don't exist. So I think that's really good news. A great example of a case that should be repeated much more often. Think of whatever authority maintains your local roads, right? Your roads, roadside assistance authorities. Also people with a lot of infrastructure generally. Think of like a company like Walmart, all the stuff they have to repair, from lights to freezers and all sorts of other stuff. All that infrastructure in Walmart. There's a tremendous amount of stuff. Think of also, like, local state roadway authorities, rail companies. Think of that. And this is something that I think is a huge potential. And I think these people need to do more about it. So it's nice to read about this from the U.S. Coast Guard. The next thing is from Core Industrial Partners. So Core is a company that takes an awful lot of money and uses it to consolidate American manufacturing. The general thesis is this. There are a lot of mom and pop CNC shops in the United States. There's no real natural company to buy these, right? There's no local bank or a local, I don't know, guy who has sells secondhand cars, won't all of a sudden think, oh, I'm going to start a CNC shop, or I'll buy that CNC shop maintained by Mrs. Roberts. I'll buy that from her when she retires. It's also, there oftentimes is not enough management buyout, or enough money in the rest of management or in the team to buy out these things as well. There's no natural kind of predator trying to consolidate these things. Meanwhile, the United States industrial bases are declining. A lot of cheap manufacturing has gone overseas, but there's a lot of, like, really high-end stuff like satellites and custom components and medical stuff that the United States wants to keep in the United States, in the U.S. And at the same time, also, it makes sense oftentimes. If you're a medical designer and you want to make medical products, it means a lot to you if you can talk to these people directly and look them in the eye. If you're a product that changes a lot, it means a lot to you. You can get in a car and drive to these guys and talk to them. So that local kind of presence really makes sense. So Core is one of the few companies that is consolidating them. They have so far consolidated, I think, over 11 3D printing companies alone. Phoenix Proto, Go Proto, I think. They have combined a bunch of them at Fathom, and combined a bunch of them in something called Uptiv, which sounds very cheery. And now they have much more ammo. They have exactly $800 million in capital that people have pledged to give to Core. $685 million is for the Core Industrial Partners Fund 3. and 200 million is for the Core Industrial Services Fund. So far, the company has raised raised and pledged in total 1.5 billion. That's a considerable amount of money for a shopping spree, and now they're going to go on to even more of a shopping spree, of course, with this money. Now, they're doing this at an incredibly opportune time. The VC money has dried up. Public money a lot of times has dried up. The SPAC stuff has gone away. CapEx is a bit lower. There's not that many strategic investors that are on the prowl. There's some family offices, kind of companies that are privately owned or have enough money to kind of think beyond the quarter. Those guys are kind of looking what's out there, but there's not a feeding frenzy. Far from it. There's a couple of companies out there that are very, very, very for sale. And there's a couple of companies from OEM to services that are essentially running on vapors. So this is a very, very nice time for Core to have $800 million or nearly $900 million even, and to go on a shopping spree. So I think this is a really, really good thing. Duck when others weave when others duck, run when others stop. This is a fantastically contrarian move where everyone is pulling back from spending on manufacturing to surge forward is an absolutely fantastic move. So great news for Core's investors, great news for Core. There are so many bargains to be had, and they could really, really consolidate this stuff. And this will really matter in serving big companies in economies of scale, and in also specialization and offering a total kind of scale and scope offering that can foresee a lot of or do with a lot of people's manufacturing needs. So I think this is a great move. Really, really smart. Zig rather zag. I think this is fantastic. So good luck to Core and its limited partners, because I think this is going to be really, really fantastic. The other thing is really, really wonderful. It's from Ethan Secor. He's an assistant professor of mechanical engineering at Iowa State. He's just got a National Science Foundation Career Award for $621,000, which is going to, the next 5 years, see him get funding for something really, really important. Now, this is something we know has been happening behind the scenes, but we don't think people have been talking about it for very, very good reasons. So this is what they're doing, is they're using aerosol jet. Aerosol jet is an Optimec technology that can be used for conductive materials, and spraying essentially materials in a kind of an organized way onto a substrate and building them up as well. And what they're going to be doing is mixing these materials, coming up with new recipes for these materials, mixing them together to come up with gradient components. So we're talking about gradient electronics manufacturing. So in a 3D space, right, layer by layer, you're going to be mixing together different materials to get different characteristics, to get this, in effect, 3D electronics out of a gradient part. So a part that could be a little bit less copper, a little bit more copper, a little bit more magnetic, less magnetic, that kind of thing. This, of course, and you've already probably realized that there's a lot of spy versus spy kind of applications for this. Obviously, this is what this stuff is being used for up until now. Obviously, there's a lot of electronics uses for this. There's IC packaging, there's antenna, but there's a ton of intelligence service kind of work that's being done in this area, which is nice that somebody's getting, like, publicly getting an NSF grant for this rather than just like on the down low trying to research this. Because we have an idea that, like, this is like a bit of an iceberg in the research department where there's like a ton more going on than we're actually finding out about, just given the capabilities of this equipment and giving what you could do with it. Yeah, there seems to be a very, very low level of curiosity in researchers in trying to print 3D electronics. And yeah, we're like, not so sure that that's reflected in reality. So here, with that expanded geometry, with mixing in these materials in novel ways, you're going to get a completely new material, completely new properties. And you're going to be able to make sensors, for example, and strain sensors and other communication sensors and antenna that can be much, much reduced in form factor, conformal, for example, with a person or some kind of craft or building. And they could do a lot of stuff that other sensors cannot. So there's a lot of applications here in defense and espionage and stuff like this. But there also could be very well in future years many more applications beyond this. Imagine, there's hundreds and hundreds of kilometers of wiring on aircraft. Now, on a consumer or on a passenger aircraft, you probably want to keep things as they are. But on a drone, for example, you may see quite quickly certain wiring type applications be relatively quickly, certain wire type applications be replaced by kind of these traces. Because it's a drone, of course, and it's not a safety critical. And this is a huge, this has potentially very, very significant impact, because we could see the changes of form factors of electronics technology. We could see something, for example, like better. Imagine just getting a slightly better antenna. Imagine somebody could figure out how to get a slightly better 5G antenna to work. just a little bit better, that would be huge for a party like Apple or a company like that. Imagine somebody could make these antenna much more compact so they can fit more of them more comfortably in the new iPhone. That is also a huge impact as well. So this is something that has a very direct, very immediate, very considerable impact on the government work and also like billions of devices. So it's wonderful, and I think it's nice that this kind of stuff is coming into the open. I think as opposed to it not being shared previously. My name is Joris Peels. This is 3D Printing News Unpeeled, and I hope you found this valuable for you today. Have a great day.